First question is, what is server virtualization? Virtualization, as the name indicates, is an act of creating something virtual. That is something which is not real. What happens in server virtualization is that the actual physical resources are hidden from the user, and each physical server is split into multiple virtual servers. Let's go ahead and see this in more detail so that you understand this clearly. Look at the left side of the screen, the left image on the screen. This is taken from the VMware side. This is something which happens on your laptop, let us say, or on your desktop. That is, you have the physical hardware, an Intel i86 machine or AMD machine, whatever. And in it, you have your networking cards, you have your disks, you have storage cards, and so on. This is accessed by the operating system directly. So on your laptop, for example, you may have a Windows 10 system or you may have loaded Linux. Now, there is only one operating system, and that operating system is accessing all the physical resources, be it memory, be it your network card, be it your storage. So what people found out was that when the servers became very powerful, the amount of CPU usage that happened was a fraction of what could actually be achieved. That means your CPU usage would be around 20% or 30% when your application was running at full speed and full steam. At this point, people started asking, so what's happening to the other part of the resource? That is, your CPU 70% is lying idle, your memory is not used efficiently, so what should we do? And this also led to this concept of virtualization. So in virtualization, what happens is, you don't allow the operating system to directly interact with the physical resources. Rather, you would introduce a new layer in between the operating system and the physical resources, and this layer is called as an hypervisor layer. Here on the right side of the screen, in this diagram, you can see something called as ESX server. Now that ESX server, whatever is the ESX that is put there, is what is called as an hypervisor. Now this hides all the actual physical resources from the operating system. If it hides from the operating system, then how does the operating system access that? Now, this particular hypervisor presents certain physical resources as virtual resources to the operating system. That is, it will show the operating system that the operating system has access to memory, it has access to disk, it has access to network cards, but it is not the real physical access, but rather it is giving a virtual access to it. When it does that way, it can now run multiple operating systems on top of it. So if you see the left side of the screen, in one physical server, you could run only one operating system, whereas on the right side, you see you're running now two operating systems. How is this possible? This is possible because this particular layer called the hypervisor layer is virtualizing your physical hardware, and then it is providing each of these operating system with some physical resources. The operating system think that they have physical resources, but in truth, they have only virtual resources. And this ESX server here, or the hypervisor, takes care of ensuring that whenever there is a call to the memory, whenever there is a call to the CPU, the appropriate resource, the real physical resource, that is translated and sent to the real physical resource. So that's the job of the hypervisor. The hypervisor virtualizes these physical hardware and presents it to multiple operating systems. So now what happens is, earlier you were running only one operating system on one CPU or one physical machine. Now you can run multiple operating systems on the same physical machine by using what is called as an hypervisor. This is what is called as server virtualization. So each of these operating systems that run is called as a virtual machine. So on the right side of the screen, you can see we are now running two virtual machines. So they are also famously called as VMs, or virtual short form for virtual machines, and we have multiple virtual machines running on a physical server. So here is a view of the hypervisor. As you can see here, the lowermost part of this diagram is the host hardware, and the hardware could be CPU, memory, network card, hard disk, etc., the IO card, and on top of it there is an hypervisor. Here it is called as a Zen hypervisor. It comes from the Zen open source. Now Zen hypervisor, on top of it you see there are what are known as guest OS. Each one of these is running inside what is called as a virtual machine. So we have n number of virtual machines running here, and each of the virtual machine will run an operating system. And also remember, each of these virtual machines can run a different operating system. So you don't need to run the same operating system in all these virtual machines. So your hypervisor will ensure that you can run multiple operating systems on the same physical hardware. So this is the broad outline of what is server virtualization. Now, let us see what are the popular hypervisors that are used in the market. VMware is one of the leading companies in this space, and their hypervisor is called ESXi. Microsoft also has an hypervisor. This is known as Hyper-V. Then from open source we have Zen. Amazon actually uses a customized version of Zen. Another open source project is KVM. And finally we are talking about Oracle having something known as Oracle VM. These are the popular ones. There are a few more which exist, but for our purpose this would serve. Now these virtual machines are what are known as generally multi-tenanted. What do you mean by multi-tenanted? Multi-tenanted, as this diagram would show you, is about what virtual machines are running on the hypervisor. What does that mean? Let's take a cloud scenario. Amazon would run a virtual machine. Now what virtual machine that Amazon runs for you will be running on a particular hardware, a particular hypervisor. On the same hypervisor, there would be another virtual machine running which could belong to a different person. In other words, you are multi-tenanted there. You are one tenant, there is somebody else who's another tenant. So in this diagram shows you there are two virtual machines of one account number 1. Then there is one virtual machine for account number 2, another virtual machine for account number 3. Most of the cloud providers give you multi-tenanted virtual machines. So when you are asking for an instance, when you're asking for a machine from the cloud provider, be it Amazon, be it Google, be it Microsoft, be it IBM, all of them provide you with a virtual machine. And that virtual machine generally is multi-tenanted. Of course, all of them would give you a dedicated one, a single tenant virtual machine we call it, if you need it. But the default mode, which most of the cloud providers work, is known as a multi-tenanted mode. So what is single tenancy? A single tenancy is where all your virtual machines are running on the same physical hardware, or it should be the other way around, let me put it, that on a particular physical hardware, only the virtual machines pertaining to your account are running. Only your virtual machines run. There are no virtual machines of anybody else running. So this is called a single tenant. So multi-tenant means multiple virtual machines of different people can be running on the same hardware, whereas in the case of single tenancy, we are talking about all the virtual machine belonging to the same account, the same person. Now, virtual machines also provide you certain advantage. Now, one of them is that you can do a lot of transparent failures. I mean, not failures, I would say transparent failovers. What does that mean? You are finding that a particular physical machine is going to have a problem, then these virtual machines can be moved to other physical machines without disrupting the connection. That is, you will be connected, and then these physical machines will be moved. So this, for example, VMware calls this as vMotion. So it moves the physical machine, it moves the virtual machine from one physical server to another, transparent to the user. So this becomes very important for us because this reduces the downtime. Because if there is a physical hardware problem, we are not worried because the cloud provider is automatically moving our VM to some other physical server without us being impacted. This is a very important feature. Let's also look at what could be the advantages of using the virtual machines. First thing, of course, we saw it's the optimal use of all the server resources. So that instead of your server running at 10%, 20% utilization, your server CPU, your memory, hard disk, everything is running at a much higher utilization. So for the cost that you pay for the server, you are getting the maximum benefit. Second is that we can easily clone the virtual machines. Again, I'm not getting into the depth of what is virtual machine, what is cloning, except that we can say that, I have one virtual machine. I want another machine exactly the same like this. I can easily get it. So instead of, let's say on your data center, you want to put up multiple systems where each system should be similar to the other. So you generally have an image, you want to load each one of them and into each of the servers and do the whole operation. It's a lengthy process, whereas in VM we can just clone the VM and start it. So it becomes much easier to clone a particular VM. So use a one VM, generate VMs which are very similar to that and start them immediately. We saw earlier that this also gives you better fault tolerance because we can move the VMs wherever we want. And very important for the cloud providers, you get an optimized load distribution. What does that mean? That means that I have 20 physical servers. So let's take the case of somebody like Amazon. Now Amazon is going to have hundreds of physical servers, and on each of the physical server is going to start multiple VMs. So when a load on one particular server becomes more, he can move a VM from that server to some other server transparently, thus distributing the load in such a way that there's a very little impact on the users. Users will not see their VMs going slow down now, the machines are working slow and all that. Rather, this helps them very transparently to move the VMs in order to distribute the load. It's not just for the failure part that we need to move the VMs. Sometimes you also move the VMs in order to ensure there is a good load distribution. So these are some of the major things about server virtualization. Hope you got an idea of what is server virtualization and why it is used. And in cloud, all systems that you get by default are multi-tenanted virtual machines. Of course, there are some like IBM and Oracle which provide physical machines if you want, but most of them by default provide virtual machines, and by default all these virtual machines are multi-tenanted. So keep these words in mind. We are getting a VM. The VM is called as an instance in Amazon, which you will learn later, and you are getting a multi-tenanted VM as a default. This is very important. Understanding server virtualization is a very, very important step in going forward in the cloud, in understanding certain things which happen in the cloud. So hope you have a good idea of this. If not, go through this again, understand it deeply. You need to read certain papers, please do read it, but ensure you have a good grip on server virtualization. Data center or have worked in a data center. The first thing is, what exactly is a data center? Here is a definition which I have taken from the Palo Alto Network site, because this gives a very good idea of what a data center is. A data center is a facility that centralizes an organization's IT operations and equipment, as well as where it stores, manages, and disseminates its data. So essentially, this is the heart of your IT in an organization. This is where you keep your servers, this is where you keep your network equipment, and this is where you store your data. So let us see what are these things that you have within a data center. First of all, if you have not seen a data center, here is a picture of how a data center looks. Here you see a lot of what we call as racks, a rack after rack, and if you notice, there are certain cables running upwards, and this is a very neat data center and very well lit up. Now let us look at each component within this. The first important component in data center is a rack. A rack, as this diagram shows, are the ones which hold your equipment. Here you can see some empty racks, some racks in which we have pushed in the equipment. So a data center generally has standardized racks. Standardized here I mean by the height and the width of the racks. So you know, if you want to keep a certain number of equipment with certain sizes, how many racks you would need. How do we know this? What are the standardizations? Let's look at that. There is something called a rack unit which is defined. This is a standard across the industry. So when somebody talks about racks or somebody talks about the size of equipment, like the size of your servers, most of the time they will talk about rack units, or what generally abbreviated as U for a unit, but it's a short form of RU, and RU itself is a short form of rack unit. So rack unit is defined as 44.5 millimeters or 1.752 inches in height. So the whatever rack you saw, that is generally what is called as a 42U rack. That means the total height of the rack would be 42 into 44.5 millimeters, more than 5 feet. Now, every equipment is made as a multiple of these rack units. So if you have a server, the server will either be 1U, which would be 44.5 millimeters or 1.752 inch, or the height of the server will be double this. That is, you will not get a server whose height is 2 inches because it's not a standard size. So all manufacturers, whether it is server manufacturer, whether it's a storage equipment manufacturer, or whether it is a network equipment manufacturer, manufacture their equipment in multiples of the rack unit size so that it can be pushed into the rack and it occupies exactly the space that is given by the rack unit. So you can stack up one over the other and you know how much space a particular equipment will take by just telling the size of that equipment. So I can say I have I have 1U servers, then a 42U rack should be able to take 42 servers of 1U size, and so on. So if you have 2U servers, again, you should be able to put in 21 servers in that rack. So your planning becomes easy. It's all standardized. The rack size is standardized. That's why when you saw in the first slide, it was so neatly arranged because all racks are of the same size. Here are some examples of rack mounted servers. Here you see the servers from the bottom on are 1U size, and the server at the top is at a different size, right? It's probably a 2U server. So you can see how they are fitted into the rack. So each one just slides into the rack, and you have multiple such servers sliding into the rack, and it's much easy to install because the size is known, the depth is known, and so on. The next thing that we look at from the data center perspective is the data storage, right? As the name indicates, data center is where you store your data, and therefore you require storage equipment. This is a front view of a storage server. Now, those small red color strips you see on the top, there are part of disks that get inserted into this particular storage array. So if you see from the left, there are 4 disks already inserted, and there are some gaps. That means in those gaps you can insert more disks whenever you want. These disks are all detachable disks, so you insert a disk, you remove a disk, and if you need more space, you come and insert another disk. Again, the disk sizes are standard. The rack size of the storage equipment is again standard. It could be 3U, it could be 4U, depending on what the particular manufacturer is selling. So this is a view of how the storage equipment also fits into these racks. The next equipment that we would see is the network switches. Here again, they are also put into racks. They also have standard sizes like 1U, 2U, and so on, and they are cabled together so that the cabling would be necessary for internal communication as well as external communication. And network switches are very, very important, as you know, because no data center is going to be isolated. It needs to connect to a lot of servers within the organization and in many cases to the internet. Have a look at the cabling here. This is a view of a very, very tidy cabling. You can see cables of different colors. Generally, many data centers would color code their cables. Suppose the cables are running within the organization, they are only for LAN, they may have a different color, and if there are cables which are running which are connected to a switch and the switch is connected to internet, they may have a different color for the cable. If you are having a fiber channel sort of cable for storage, that would have a different color, and so on. So it's up to the concerned enterprise to decide on how they want to color code the cable and ensure they understand which cable goes where and how. And cables are also labeled and so on, but that will not get too much into exactly how the cabling is done, because cabling is a very, very tricky affair, and as this particular slide shows, it can really get messy because you have a lot of equipment internally there. You have servers which need to connect to each other through a switch, and then there are storage boxes which may connect to the servers over fiber channel. The cables are required for that, and so on. So there are a lot of cables, running in the data center, and cabling is a very, very huge task, and it's a very complex task. Then we come to the location of a data center. So where is a data center located for a company? The data center can either be located internally, which means in the premises of the company. So the company will have to provide the space for that, and the whole thing is internal, and it could be handled internally, or you may ask a third party to handle the complete data center for you, but the location is internal to your company in your own premises. The other option, of course, is to set up your data center as a hosted data center. That is, you give a third party the responsibility of setting up the data center for you and probably managing the data center for you. So they set up all the equipment that you need, and then they give you the necessary connections so that you can connect to the data center and start working, but the whole equipment is at a different place. So in order to run the data center, what else do you need? We of course spoke about the equipment that go into the data center, the servers, the networking, the storage, and so on. But additional to that, what is required? First, of course, you need the facility. Basically, when I said facility here, we mean about the space. So the company has to find a space where you can host these different racks. So depending on how many racks you have, you may
need that amount of space. So the space has to first be provided for a data center. Then you have to provide power. You have to try to see how you get power as uninterrupted power supply as well. So you must have UPS backup for your power because you don't want all your servers crashing at the same time. You must have environmental control, which means that you must have heating, you must have cooling, you must have ventilation, there must be an exhaust, and so on. And data center is the heart of your whole IT operations, so it has to be extremely secure. So in that case, you need to ensure that only authorized person enter in the data center. So you could have biometrics, you could have video surveillance of the facility. You have to set up all this so that you have top-notch physical security. Finally, you will need operations staff, obviously. So if you are managing it yourself, then the operations staff is needed because it could be the staff who maintain the IT part, or the staff who look after the power, the staff who look after the cabling, the staff who are in charge of physical security, and so on. Now you have an idea of the data center, and you can also now understand why many people want to move to the cloud, because handling a data center is not an easy task. You have to have a lot of space, then you have to have power, heating, cooling, and so on. You need a large operations staff to operate it, and you have to have other support systems like biometrics, video surveillance, and all to do that. So the value proposition that the cloud has is that it takes this away from you. So when you say cost saving on the cloud, you're not only talking about an instance based saving, or saving because you are taking up a machine there and you're shutting it off and they don't charge you for the time that you don't use, sort of thing, but you're also thinking about all this. How much power would I save? How much cooling would I save? How much would I save on operations cost? How much would I save on the equipment like biometrics equipment or video surveillance equipment, and so on? So the value proposition of the cloud goes beyond just cost on one-to-one basis in terms of servers or storage, but also that this major task of running a data center is taken away from you. So you have to understand this, and then you will understand what or why people want to move to the cloud. Hope you got a decent understanding of what a data center is and what is done there.
Another important topic which is necessary for you to understand cloud and how to design solutions cloud is networking. If you're going to work in a large enterprise, or if you're already working in a large enterprise, without understanding networking, it's impossible to design a good solution for the cloud. This is because of various reasons, because networking is a key concept which will enable certain machines to be seen by the outside world, certain machines not to be seen by the outside world, and will ensure that there is a certain protection to the overall infrastructure. So to understand what is networking is very important. So if you're already a network engineer, all what I'm going to say is very, very basic. But if you are not, but you have only been working in storage area or server admin, or don't have much knowledge on networking, this is a very basic that you should understand, because in later places where you see networking related videos, you will see that this becomes very useful for you. So let's start. Let's look at the IPv4 addresses. Now this I think is very trivial and all of you would know it. But anyway, let us look at it so that we have completeness here. The IPv4 address, as you could see, is a dotted decimal notation address. And each of the numbers before a dot here is made of 8 bits. That means that the number can go from 0 all the way to 255. That is 2 to the power 8 is 256. So you get 256 numbers starting from 0 to 255. So each of them is 8 bits or 1 byte. So we have a total of 32 bits in an IPv4 address. We're not talking IPv6 here, we're talking about IPv4. So in IPv4, you have 32 bits available for you for addressing. So this is the IPv4 address scheme. So 8 bits each or 1 byte each and 4 bytes next to each other with a dot in between them. The other concept that we need to understand here is the concept of subnets. Subnets are a logical subdivision of IP network. So you have your own division. You want all people in this division to be a part of a network, and that we call as a subnet, let us say. So what does that mean in technical terms? It means that they all have a certain commonality when it comes to the IP address. So what is this commonality? The commonality is that their most significant bit group in their IP address would be identical. So when we do that, you can logically divide networks. So one particular network can get a certain most significant bit group to be the same, another gets a different most significant group to be the same. So what is this most significant group and things like that? I'll just explain to you. So when you divide this, you get two parts here. One is known as a network prefix and other is known as a host identifier. So the network prefix is what I called as the most significant bit group. The network prefix will be the same for a subnet. So if you have a subnet, the network prefix is going to be the same for the complete subnet. Only the host identifier will keep changing from server to server within that particular subnet. So let's have an example here. Now I can have a subnet starting from address 192.168.1.0 all the way up to 192.168.1.255. Now here 192.168.1, the first 3 digits that you see here, 192.168.1 is known as the network prefix. So that remains unchanged. So within your subnet, everybody has this prefix, that is 192.168.1. So what changes is the last number. So the last number is what can change from 0 to 255. Generally, again, I'm not going deeper into networking here. 0 and 255 are not available for us because of gateway, broadcast and other things, but don't worry about it. The idea what you need to understand is the network prefix, that is 192.168.1 here is what is going to be common to everybody in your subnet. So each one will have a different IP address, and that IP address will differ only in the 4th digit. So you may have an IP address of 192.168.1.10 and a colleague could have 192.168.1.15 or whatever, like this, right? So this is an example of subnet. Now in order to define the network prefix and in order to define what could be your host identifier range, there are multiple ways of doing it, but the most common way that's adopted and the way that you will see, earlier there used to be, even now they're class A, class B, class C type of addresses, but in Amazon where we are going to do our exercise, we will use what is known as a CIDR notation or CIDR, which generally pronounced as CIDR notation. The full form for this is classless interdomain routing. Now this is the method of allocating IP addresses to subnets. Now you write it in a format where you write the base IP address and then a subnet mask, what we call as a subnet mask. This is the format in which it's written, like 192.168.0.0/24. So what does this mean? Well, let me explain that to you. Now, this explains the CIDR notation. The /24 we see, let's look at the /24. What does it say /24 says that your network prefix, we saw about network prefix earlier, your network prefix is of 24-bit length. 24-bit length is 3 bytes. So the first 3 bytes, or the first 3 numbers, are going to be a network prefix, which essentially means you can only change the host identifier, which is the last number or the last 8 bits. So the slash and whatever number follows indicates to you what is your network prefix. That is, how many bits, the topmost bits, are common for your subnet, and which means that the remaining bits out of 32 are the ones that are for the host identifier. So let me work out a few examples for you so that you understand this concept clearly. Let's take the example here. I'm giving you an address called 192.168.1.0/24. Now the total bits on IPv4 we know is 32. In this example, the first 24 bits are the network prefix. So this would mean that the last 8 bits, how did we get 8? That is, 32 is the maximum bits minus 24, which is for the network prefix, because the network prefix remains common. So if I minus 24, I get 8 bits. So 8 bits can give rise to 2 to the power 8 numbers, which means that I can have 2 to the power 8 IP addresses for the host identifiers. So I can get up to 256 IP addresses. 2 power 8 is 256 addresses. So I can get 256 addresses. So my address range now for this subnet will become 192.168.1.0 all the way to 192.168.1.255. So let's work out another example, this time with a different subnet mask. In this case, I'm going to give you 192.168.1.0/28. The base address is still the same, but I now have /28. What does this mean? This means that the network prefix is of 28 bits. So the 28 bits is common to all computers in your subnet, which means that for the host identifier, you have only 4 bits left. How do you get to 4? Because 32 is the total, 28 is already fixed for the network prefix, so 32 minus 28, you get 4 bits. 4 bits can give rise to 2 to the power 4, which is 16 numbers. So you can get 2 to the power 16 addresses for the host identifier. In this case, you have 192.168.1.0 all the way to 192.168.1.15. That will be your address range. So this is the effect of the side annotation. So the side annotation tells you how much is the network prefix and what numbers are available to you to use within your subnet. Please understand this thoroughly. I've also given you certain exercises. You can download and do those exercises so that you get very comfortable with this side annotation, because when we are doing the VPN in VPC, sorry, not the VPN, the VPC in AWS, you'll find that we use the side annotation often. So be thorough with it before you go to the VPC part. Now, another thing that we also use within our data centers and also within the cloud when we build VPC is private addresses. The internet has a designated private address ranges. This means that these addresses can be used within your company. They will not be visible outside to the internet. So in other words, you can use this range. Somebody sitting on the top floor of your same building, a different company, can use this range of IP address. A person in the third floor can use this range of IP address without any conflict, because these are local to your company. These are private address ranges. They are not seen on the internet. So there will be no clash on the internet for these ranges. These are designated private ranges. The first range, that is something which many of you would have seen in your home computers or in office is the 192.168.0.0/16. So starting from 192.168.0.0 all the way up to 192.168.255.255. This is an address range which is a private address range. Similarly, we have the 10.0 address range. Here starting from 10.0.0 all the way up to 10.255.255.255. This range is again a private address range, and we have the 172.16 range where this is from 172.16.0.0 to 172.31.3.255.255. Now what I want you to do is also look at the side notation here and check if the number ranges that are given here are correct and why are they correct. So when I say 10.0.0.8, does it really translate to 0.0.0 till 255.255? And if I say 172.16.0.0/12, what's the range? The range that I've given here, is it correct or not? You should be able to look at the side annotation and tell me whether it's right or not. Other two things that you would want to understand are the routing table and gateways. So let me look at a routing table. A routing table is a set of rules, generally in a table format. Now, this is what determines where your packets go. So when you are sending out data from your computer to some other IP address, how is this packet to be routed? So that rule resides in this routing table. So when I want to go to the internet, the routing table will decide, okay, where should I send this packet so that it can reach the internet. Suppose I want to go internally. I have an address which is internal. The routing table says, okay, this is a LAN packet, so let me send it internally in the LAN. So this table is a very, very important concept in networking. Without routing table, nothing works, you can say, because it's the routing table which knows where what packets can be, where what packets should be sent. Right? So all IP enabled devices, whether routers, switches, anybody, all of them use routing table. So routing table are ubiquitous. They are everywhere in the networking scheme of things, and you should understand this. So here is an example which I've shown the routing table. So here you can see that there's something called as a destination. So we are saying from my server, if there is a destination of a particular IP address, where should this packet end up going? So if I have a destination of A, should I send this packet to a certain gateway? Should I send it to different gateway? Where should I send it? So the routing table will have these rules. So the routing table has the rules of what is the destination? If this is the destination, where the next stop that the packet should go. Then we have the concept of gateways. Now, a gateway is a node in a network, in a computer network, or a router in a computer network. This is what connects two different networks. So, for example, you are inside your company or inside your house and you're connecting to internet. There has to be a gateway which connects between the network of your house or your service provider to the internet. Similarly, if you are in the company, you want to connect from your company outside to the internet, there has to be a gateway which connects to it. It's not necessarily only to connect to internet, but it is to connect two different networks. So you are in a network, and there's another part of a company in a totally different network, and you need to connect both of them. Then you need a gateway device which can connect both your networks. So that's what this particular definition from whatsmyipaddress.com says. A gateway is a node in a computer network, a key stopping point for data on its way to or from other networks. Okay, thanks to gateways, we are able to communicate and send data back and forth. The internet wouldn't be of any use to us without gateways, right? So this is very important. So the gateways are the one which open up things to you, and that's why they're called as gateways. And in the case of Amazon, when we do the VPC, you will find there's something called an internet gateway. Now then you will understand why there's a need to connect an internet gateway, because that's what will help you go out to the internet. This is a a simple diagram which gives you an idea of what is a gateway. So you have multiple hosts and there's a gateway, and that gateway allows you to access a different network. So the machines on the left side of the screen are all on one network. The network shown on the right side is a totally different network, and through the gateway you are accessing the other network. So these are some of the basic things that you must know about networking when you go ahead to do the important parts like the VPC. Hope you got some idea of this, of networking. Be thorough with the side annotation. Understand what's a routing table. Understand what's a gateway, because this is something which we will use very much when we do the VPC. Thank you. In this module, we will talk of another important aspect of the cloud, the storage aspect. So understanding storage is also very important when you want to understand cloud. We already saw something about server virtualization. Now let's look at what is storage and how storage is used in cloud. Storage can be classified under these four types. The first is known as a direct attached storage, or DAS as they call it. Then there is network attached storage, or NAS. Then we have storage area networks, and finally we have object storage. So let's go and look at each one of them in detail. Direct attached storage, or DAS, is the most ubiquitous storage. It's available everywhere. What it means is that it is directly attached to the server. You take your laptop, you take your desktop, you have a disk inside. So that disk is directly attached to your server. It's a physical attachment between your server and the storage disk which is there. So that's a direct attached storage. Suppose you take a USB drive and attach it to your system, that also becomes a direct attached storage. So there's no networking, anything involved. You just plug this in either directly through a IDE cable or through a USB cable. All this becomes a direct attached storage. It's everywhere. You find them in desktops, it's there in laptops, it's in mainframes. So direct attached storage is something which is present everywhere. This is a diagram which shows you what is direct attached storage, as you can see. So there are server modules, and then you have a direct attachment from the server nodes to the storage. Next comes the network attached storage. So let me explain this by the diagram here. Now in this case, we have a lot of servers which are called as the NFS clients, or clients here, and they are on a LAN, or a local area network. They are connected to what is known as a NAS server. Now all of them have access to this NAS server, and the NAS server is the one which has all the storage with it. So what they do is they do something called as they mount the NAS server's directory as if it is their own directory, and then they use it. Let me give you an example which you would probably be doing often. So if you are in a large corporation, you may have what is called as a NAS filer. You would have mounted it as your own and used it. Even if you have not used something like a NAS filer, you would have used shared folders. Suppose you're working on Windows, you have a colleague, and the colleague shares some folders so that you can transfer certain project files. Now when you mount that folder onto your system, that becomes a network attached storage. So network attached storage will provide you a file interface, and that file interface you will mount as your own file or your own folder, and then you start working on it as if it is residing in your system, though actually it is residing somewhere else. So this is called as network attached storage. Now the server which you saw in the diagram, which connects to the storage, is called as the NAS head or the filer. We call it as NAS server or the filer. Filer is a short form for file server. So The clients will be on a LAN. They will access these files over a normal Ethernet connection. The protocols that are used here are the famous NFS protocol, which is used by the Linux systems, and CIFS protocol or CIFS protocol, which is used by the Windows system. Now, the next part is about SAN or storage area networks. A storage area network nowadays come in two forms. One is a fiber channel based storage area network, and the other is an iSCSI based storage area network. So let's look at FC SAN or fiber channel SAN first. This is a typical FC SAN setup. Here, there is something called as a fiber channel switch which resides in your network. Your servers connect to this particular switch through a special card called as an HBA or host bus adapter. This is a special fiber channel card, and using a fiber cable, your card is connected to this fiber channel switch. On the other end of the switch, you have your storage devices. It could be RAID arrays, it could be JBoards or other tape libraries or whatever, but those are all residing on the other side of the switch, and the switch is used to connect all of them. So this is a fiber channel, typical fiber channel setup. So here there is no direct connection to the device. It happens through the switch, and the switch is connected to your device through a HBA. Then comes the iSCSI SAN. Now, iSCSI SAN works over Ethernet. It doesn't require a special host bus adapter. All it requires is a normal network card, and over the LAN, over WAN, it can work. And through the Ethernet switches, which are anyway present in your Ethernet networking, it connects to the devices on the other end. So the devices on the other end which connects to are generally called as iSCSI targets, and the servers which connect to them are known as iSCSI initiators. So there's an initiator, there is a target. You are the initiator if you are a server, and the target is the disk array to which you want to connect. So this is the iSCSI model. Now, depending on the cloud provider, you may know about these models or not. They may not tell you whether they are using iSCSI in the backend or fiber channel in the backend. So for example, if you take EBS of Amazon, that's the Elastic Block Store of Amazon, we do not know how they implement it. I mean, I don't think they have documented it. So you don't know if it's over a fiber channel SAN or over iSCSI SAN. That's transparent to you. You need a disk, you get a disk. That type of thing. But in some cases, like in the soft layer of IBM, they do tell you that they don't use fiber channel SAN and that they use iSCSI SAN, and you have to go through the whole process of iSCSI initiator, target, discovery methods, and so on in order to mount an external device. Whereas in cases like Amazon, you don't need to do it. It's automatically done for you. The whole protocol is transparent to you. Then we come to the object storage. Object storage is slightly different from the file and the other storage that we mentioned till now. Now this is a storage which cannot be attached. Now in the first three cases, that is in direct attached storage, we attach the storage, physical storage directly to the server. In the case of file storage, that the network attached storage, we are attaching a file system to our server. In the case of a SAN, whether it's a fiber channel SAN or iSCSI SAN, we will attach a virtual disk. That's the difference between direct attached storage and storage area networks. In the direct attached storage, you attach a physical drive directly to your server, whereas in a SAN, you will attach what is called as a virtual drive. So you attach a virtual disk to your server. Whereas in object storage, you cannot attach the object storage to the server. Rather, object storage is a space somewhere else, and the object storage does not have what is called as a hierarchy. Normally, when you take up your file system, whether it is in the case of file storage, that is a NAS storage, or in the case of SAN storage and others, you will have a file system. So where you have a root folder or root directory, and under that you can have user directory. Under the user you can have multiple directories, and also a hierarchy is formed here. Whereas in object there is no hierarchy. It's all what is technically called as a flat namespace. So there is no hierarchy, there are no directories there. You just dump all your files into one single namespace, into one single place. Now here, the difference between, again, what we saw earlier and about object store. In the object store, the metadata about the object is stored within the object. Whereas in the other case, where we saw the files, in that case, the metadata of the object. What's the metadata of the object? The metadata of the object would be details about the file, that is, when was the file created, who created it, who has permission to access the file, when was it last accessed, and so on. Those details are kept separate from the actual data when it comes to the direct attached storage, when it comes to network attached storage, and so on. But in object store, you keep all the data within the object. So the data plus the metadata reside in the same place, reside within the object. And you use the object ID to access the object. Here we have to do get from the storage and then put to the storage. Whereas in the case of the files and in the case of direct attached storage, we are going to do read write because they are attached to you. You can do read write. Whereas in an object store case, we have to get the object and we have to put the object there. So to understand this particular difference, here is a small table which gives you the difference between these two. The direct attached storage that we saw and the storage area networks that we saw, the iSCSI SAN or FC SAN, all of them form under a category known as block devices. What does block device mean? A block device means it is mounted onto the system as what is called as a block device, and then the server is responsible for formatting the disk, for writing the file system on the disk. So formatting the disk is the responsibility of the server in the case of a block device. As I said, the block device could either be a direct attached device, or it could be FC SAN, or it could be iSCSI SAN. The file sort of storage is what we saw in the network attached storage. Here, you do not format any disk, that you don't do. You just connect to a server which has a file system already built. So somebody has formatted this disk, somebody has built the file system there. All you're doing is you're taking the file system and mounting it as your own file system and then starting to use it. So that's the difference. So the key difference between block and file is that in block, you are responsible for formatting the disk. In file case, you don't format the disk, you just take the file system and start using it. You mount the file system and start using it. So let's look at this comparison here. In object, as I said earlier, there is no hierarchy, there is no file system. Whereas in a block and a file, there is a clear hierarchy. That is, there is a file system. In block, you build the file system. In the file case, already the file system is built. Object, you cannot mount an object. You have to get an object and you have to put an object. Whereas in a block case, the disk is mounted. It could be through the FC, it could be through iSCSI, it should be through a direct attach, which could be IDE or other protocols. Whereas in file case, in a file storage case, we mount it as a file system. The object is accessed via the REST API. A block device is accessed via SCSI or FC or iSCSI or IDE. There are multiple protocols which are used to access block. Whereas file is accessed as NFS if you are having a Linux server, and through CIFS if you have a Windows server. In object, the metadata is stored within the object. We saw that. Whereas in a block and in file, metadata is stored in a separate place. It has a designated place where metadata is stored, and the data is stored in a different place. Objects are immutable, which means you can't edit them in place. Whereas in block and file, the files can be edited in place. Now, block and file, the scaling that is possible, that is the number of files that if you keep on putting more and more into the block and file devices, after a certain time you will see the drop in efficiency because they have a hierarchy and you have to search for every file through the hierarchy, which could take a long time. Whereas in an object store, since there is no hierarchy, there is a flat namespace, the search becomes much easier, and therefore whenever high scales are required, like the scale at which we see Amazon or Google or Microsoft working in the internet scale, as we call it, in the internet scale, there is no choice but to use object store because of the high level of scaling that is possible using object store. So hope this gives you a clear idea of object, block and file, and depending on the cloud provider, you may understand you may understand all this, or let me put it this way, they may sort of expose all this to you, or they may not expose it to you. So each of them has a solution for object store. For example, Amazon has S3, Azure has its own object store, Google has its own object store. Similarly, all of them would probably have a file solution. Azure has its own file solution. Amazon has something called as EFS for the file solution. And for block storage, all of them have block storage which can be attached to your system. So depending on the service provider, the amount of protocols or amount of data about the type of storage exposed would differ, but it's always good for you to understand what type of storage you're using, whether you're using a block storage, whether you're using a file storage, or whether you're using an object store. So this gave you a bit about the very basic level of storage, but I'm sure this will help you in understanding the cloud better. Thank you.
One of the important services of Amazon AWS is the load balancer service, or the elastic load balancer. Before we see what is an elastic load balancer, it's good to see what is a load balancer and get to know the basics of load balancer. So this module is going to take you through the basics of load balancer. We are going to find out what is a load balancer, what does it do, why is there a need for a load balancer. I take this definition from a company which makes load balancers called F5 Networks. And as you can read here, what they say is that a load balancer is a device that acts as a reverse proxy and distributes network or application traffic across a number of servers. Load balancers are used to increase the capacity so that you get more concurrent users, and also the availability and the reliability of the system. The performance overall is also increased, and it can also perform some application-specific tasks. Now let's see this in a sort of a diagrammatic form. Here is a diagram. Now the load balancer generally sits in front of a set of servers, and when a request comes to the load balancer then sends the request to any one of the servers attached to it. So the load balancer itself will not service the request. This is very important for you to understand. The load balancer is just to accept the request. It accepts the request, and then based on some algorithms which you'll see later, it will send the request to one of the servers that is attached to it. So you can have 10 servers behind, you can have more servers behind, whatever you want, and then based on the algorithm you have set up, it will accordingly keep sending the request to one of these servers, and then takes the response and sends it back to the user. So user on the other side will only see the IP address of the load balancer. the user is only aware of the load balancer. So he thinks that he's interacting with the load balancer, but in truth, the load balancer is interacting with a set of servers in the background and getting the required response from these servers. So this picture would have made that clear to you. Now, why is it that people use a load balancer? Load balancer becomes the single point of contact for clients. This enhances your security because you can hide all your web servers behind. I mean, you don't need to show the web servers to the internet, and the internet sees only the load balancer. That's the only domain name, the only IP address that the internet could see. Second is the scalability part or the elasticity part. Scalability here is as and when the demand grows and more users are connecting to you, you can put more systems behind the load balancer. That is what we call as a scale out. We can scale out the numbers of systems which are attached to the load balancer. And assuming the demand falls, at that point in time, you can remove certain systems away from the load balancer. That way, you are now elastically growing and shrinking your system based on the requests that you get. So the more the request, the more the load, more systems you have, less the load, less system you have. So you start mapping this. What happens is you have a mapping between the need of the users or the number of users who are coming to your application, plus you also contain the cost. You don't want to run more systems when the load is less, or you want to underperform when the load is more. That's first thing. Second is high availability. Now in the high availability case, what happens? Now you have, let's assume 4 systems connected to your load balancer. If one of the systems goes down, the load balancer will start balancing the load against the other 3 systems. In the meanwhile, you can repair the 4th system and bring it up, or you can bring up another system and attach it to the load balancer. But during this time, when the system is down and you got back the system working, the application is not impacted because the users can still connect. They are connecting to the load balancer only, and behind there are still 3 systems which are servicing all the requests. That way, you will ensure that the system is highly available for the clients. An important thing here, and which comes out sometimes in the examination of the question, is what does the load balancer do when the system goes down? One of the systems attached to it goes down. What the load balancer does is it no longer considers this instance which is down as part of the group in which it has to use to do the load balancing, and it will load balance against the other systems. The load balancer per se will not do anything to bring up that system. Remember that load balancer's job is not to bring up a system which has gone down. Rather, it will take the system out from its list of servers against which it has to load balance, and will start load balancing against the remaining servers. The other thing we are looking at when we talk about load balancing is also reliability. Reliability here is that the load balancer is continuously monitoring all the instances that are attached to it. If some instance fails, you can always get an alert and you can go and fix up the instance so that you always are clearly on top when it comes to knowing which instance is up, which instance is down. So this monitoring feature of the load balancer is a very important feature which will help us to give reliability. Additionally, load balancer can work in such a way that you distribute your instances across 2 different availability zones, so that if one zone goes down, you still have access to some instances which are running in the other zone. So that's another use of load balancer, as you can see, and it's also part of the high availability use case that you would have. Now, I've told you about load balancer balances load based on certain techniques or certain rules. Now, what are these techniques? Here are some commonly used techniques listed here. First technique would be the round robin technique. round robin is simple one. The first request goes to the first server, second to second, third, fourth. If there are 4 servers, then it again comes back 1, 2, 3, 4, 1, 2, 3, 4. That's how the requests are, distributed by the load balancer. Weighted round robin means some instances attached to the server, to the load balancer, will get more requests than the other instances. Suppose you have 3 instances and one of the instances is very powerful instance. So you would say to the load balancer that I would use a weighted round robin technique here, wherein the first 2 instances go to the powerful machine, then the next 2 go 1 each to the second and third machine. Then again 2 to the first, 1, 1, 2, 1, 1. So every 4 requests, it will be split as 2, 1, 1. So one of the server takes up 50% of the request, the other 2 take 25% each. So we are distributing the load in a different manner. This is called as a weighted round robin technique. Whereas if it was 4 machines with normal round robin, each machine would have taken 25% of the requests coming in. The other method is the least connection method. So the load balancer checks which of the instances attached to it has the least number of connections, that is servicing the least number of requests at the current point in time, and based on that it will send the next request to the instance which has the least number of connections. So if one instance is servicing too many requests and is still not completed servicing those requests, the connections will be alive. So the next request will not go to that server, it will go to another server which has serviced a lot of things and lot of requests, and currently the number of connections to that server are less. That's the least connection method. Then we come to the least latency. So here we see which of the servers currently is giving the best response time. So in other words, we are seeing which of the servers currently has the least load. So we can also call it sometimes the least load. So we keep track of this and then send it to the server which is giving the best response, and that's the way this technique works. So these are the different techniques using which load balancing can be done. There are 2 types of load balancers here. One is known as a layer 4 load balancer. This balances load based on the data which is available on the network and the transport protocols. That is, it will check a TCP packet, or it will check an UDP packet or an FTP packet, and based on that it will do the load balancing. So it understands the packet structure, and it understands that it's a TCP packet, and it will take the TCP packet and the incoming request which comes in as TCP or UDP, it will take the request and accordingly do the balancing. But it doesn't understand which is the application which has sent this request. All it knows is that it's a TCP request which is coming in. The other load balancer is the layer 7 load balancer. It's also called as application load balancer or application delivery controller. So you will see a lot of ADCs when you go to any site which does load balancers. You will see that they call this as ADCs or application delivery controllers. These work at the layer 7 level. Layer 7 in the OSI layer is the application layer. This means that the load balancer understands the application. For example, HTTP, an application based on HTTP protocol, this particular load balancer can look into the packet that comes in of HTTP. It understands the HTTP protocol. It knows which field in that particular packet there would be the URL. It can pick up the URL, and based on the URL, it can take a decision on how to route. So in other words, layer 4 load balancer does not have a clue on whether it's an HTTP packet, whether it's an MySQL packet, or any such packet which is at a higher application level. It just knows that it has received a TCP packet. So it cannot make a decision based on the application, whereas an application load balancer understands the application, understands the format in which you receive packets for this application, and accordingly will route based on the application requirement. So that is a brief primer on the load balancers. Hope you got some idea. about what load balancers are. Now you can go to the module of load balancers in Amazon, the Elastic Load Balancer, and you will understand that a bit better now. Thank you. In this module, I'll be talking about the basics of cryptography. Cryptography is very important, especially in terms of the security, and encryption and decryption are often used in many services. So let us go ahead and first find out about some of the cryptographic terms and what they mean. In cryptography, you will hear terms like encryption, decryption, cryptographic keys, symmetric keys, asymmetric keys, encryption algorithm, plain text and ciphertext, and so on. I will talk about each of them in the coming slides. A plain text here refers to any text that you're storing normally without encryption, and ciphertext refers to the text which is encrypted. But what is encryption? Let's have a look. Now, if you take this definition from Wikipedia, encryption is a sort of a scheme where the intended information or the message, which is referred as a plain text, is encrypted using an algorithm. The encryption algorithm is also called a cipher, and this algorithm, when run on the plain text, will generate what is called a ciphertext. The ciphertext is generally a meaningless string of letters and numbers, and if you want to read it back, you have to decrypt it so that you can read back what was the plain text. So let me give you an example. This is a very simple example. Nobody does this. This is very trivial, but still it will give you an idea. For example, you have this word hello. Now the hello is now the plain text. I have to transmit hello to my friend, but I'm afraid that somebody can overhear this. Somebody can intercept this. So I want to transfer hello in a way that whoever overhears this is not able to understand what is there, but my friend can de-encrypt this and understand what I have transmitted. So let's take a simple case. I want to replace every alphabet with the next alphabet in the alphabet scheme. That is, if there is A, I replace A with B. If there is B, I replace it with C, and so on. And if it's Z, I replace it with A. So in this case, hello, HELLO, will now become IFMMP. So HELLO, the hello, is called as a plain text, and IFMMP is called as ciphertext. So this is the basis of encryption. Of course, when they actually do the coding, they use complex algorithms, not so simple algorithm, and they use something known as keys. The keys are used in the algorithms to encrypt your data so that others cannot easily decrypt it. Now in this example that I gave you, it's very easy to decrypt. If somebody just thinks for a while, they would decrypt it, but in the algorithms that we are going to talk about, or in the general algorithms that they use for encryption, it is very hard to decrypt it back, sometimes even impossible. In order to get a good encryption, one thing that you will need is a cryptographic key. Now, when you do your EC2 exercise, or if you have already done that, you will see that you have to download a key. It's called as a PEM file, PEM file. That is an example of a cryptographic key. So that key is used as a basis to encrypt text. So use that key, you will encrypt a plain text using a certain algorithm. There are multiple types of algorithms. Depending on what application, etc. The algorithm could vary. In this case, then when you have PIM, there is an RSA algorithm that's used. So use this cryptographic key to encrypt data. Now the cryptographic keys are of two types. One is called a symmetric key, the other is called as an asymmetric key. Now in case of a symmetric key, you use the same key for encryption. So you take a large amount of text, encrypt it using a key, and when you read back the encrypted text, you decrypt it using the same key. That's called as a symmetric key. The same key is used for both encryption and decryption. In case of an asymmetric key, you will use different keys for encryption and decryption. That is, there is one key for encryption, there is a different key which will decrypt it. This is generally called as a public-private keys. So if you look at the EC2 module, you will find that when you do the EC2 module, you will find that you have to download what is called as a private key, and the public key is available with Amazon. So you encrypt your data when you are doing an SSH using your private key, and up there the decryption will happen using the public key that Amazon has. So you use one key to encode and you use a different key to decode, or one key to encrypt and another key to decrypt. So this is called as an asymmetric keys. Another thing which is commonly used in cryptography is a digital signature. Now, user can digitally sign data so that the receiver can verify that the data was not tampered since the time of the signature. If you download things from open source, if you download something from Linux, you will find that along with that they give you a hash key, that's a digital signature. So if you want to check if there was no tampering, you will have to see that your digital signature, you can regenerate the digital signature from the data and see that it matches the signature that was sent, so that you know there is no tampering with the data after the signature was done. Another thing about cryptography here is a digital certificate. A digital certificate, you would have found this in websites. You would suddenly get a pop-up saying, the digital certificate cannot be trusted, some things like that. Now, what is digital certificate? A digital certificate is a certificate which is used to prove that you own the public key that you say you are holding. How does that get communicated to the user on the other side? So the digital certificate will have information about your key. It will have the details of the owner of the key, which is yourself, and it will have a digital signature of an entity which has verified the certificate. So if that entity is trusted by the other side, that is the end user is trusting that entity, then the end user, if he finds the signature is valid and the issuer is trusted, then the other side will pick up your public key, encrypt data using that public key and send you that data so that you can decrypt it. The TLS protocol uses digital certificates. We'll not go too deep into how the TLS protocol works and all. All you need to understand is that if you are using TLS, HTTPS, then you will need a digital certificate. So that's a sort of a overview of what cryptography is. You will hear these terms often, the public-private keys, symmetric keys, TLS, certification authority, and so on. So this gives you an idea that you don't need to be scared when you hear those words. when it concerns cryptography. So thank you for this, and I hope this has conveyed you the basics of cryptography. Thank you.
In this introductory video, let us understand what is a cloud and how is it defined. In terms of cloud, there are many definitions that exist, and people have tended to have their own definitions for what is a cloud. So if I were to ask you what is a cloud, you would give me some definition or your own understanding of what is a cloud. This is how it has been for quite some time. Here, what we are going to do is to see how is a cloud defined by a particular standards organization, and that definition is now what everybody abides to. So let us see certain things. What is a cloud? How do you differentiate a cloud from a large data center? What's the difference between, say, a private cloud and a managed data center? What are the similarities between cloud and data center? So let us see all of them. So in order to have a look at this, we must first have a clear definition of what is cloud. So to define it, we define what we call as the characteristics of cloud. The standards organization known as NIST, National Institute of Standards and Technology, had defined 5 important characteristics, or what is known as essential characteristics of cloud. So let's look at each one of them. The first characteristic is known as on-demand self-service. The second characteristic is known as a broad networking access. The third characteristic is resource pooling. This is followed by rapid elasticity, and finally by what is known as measured billing. So these 5 are the essential characteristic of a cloud. So let's go and explore each one of this characteristic in detail, starting with the on-demand self-service. What is on-demand self-service? Now, the name itself tells what it is, in the sense that there should be a self-service component, which means that the user must be able to provision resources of their own. So let's say you want to start a machine, you want more storage, you don't need to ask anyone. You just go to a portal, set up the necessary parameters, and click a button, and a machine should start for you. Or click a button and more storage should be added to your account, and so on. So you should be able to provision the resource on your own. You should be able to release these resources when you don't need them. This is in contrast to a company's data center. If you are working in a company and there's a data center in the company, there you mostly don't have a self-service option. So what you do is you have to get an approval to get a new machine. It could be a physical machine or a virtual machine, but you need an approval. And after the approval is done, then there would be an administrator who will be responsible for provisioning the necessary resources for you. Whereas in a cloud, we don't have anybody who is interfering with you. You just go and provision whatever resources you want, and the resources are given to you. And remember, this is not just self-service, but it's also on demand. You can go and provision resources whenever you want, and they will be available to you instantly or almost instantly. This is the on-demand self-service part of the cloud. And this is one of the most important characteristics of the cloud. So if you are using a cloud, remember, you should be able to perform self-service operations on the cloud, and they should be on demand. The second characteristic, which I think almost everybody implicitly understands, is a broad network access, which means that cloud requires network. So you are accessing the cloud over a network. It could be your local network if you are using a private cloud, but mostly we are talking about being able to access over the internet. And these resources should be accessible over some of the standard APIs. So you have REST APIs, which are given by most of these companies, where using those REST APIs, you can write your programs and access the resources. And nowadays, we have so many devices which we can use to connect. So mostly all the cloud vendors would want any type of device to be able to connect to the cloud. Like you can do your management through a mobile phone, you can do the management through a tablet, or you can do the management through a laptop. So a broad networking access or broad network access is something which is definitely needed for you to be a cloud. For a cloud, broad network access is a must. Next part, which is very important, is known as resource pooling. Now this characteristic is what helps cloud to scale. What happens here is the resources are not tied to one client or one user. Of course, there are certain exceptions that do exist, but in case of AWS, you will later see that there are things like dedicated hosts which are dedicated to a particular client who buys that. But otherwise, a cloud is made out of virtualization. And virtualization is nothing but resource sharing. So in virtual machines, as you will see in another module about virtual machines, you understand this better. In virtual machines, you have more than one virtual machine running on the same physical hardware. So you're sharing the resources like CPU, you're sharing the resources like memory. Similarly, storage would be on some storage array where you are getting virtual disks or LUNs or whatever are the different terminologies that you use. But these are all virtual storage devices that you are getting. So because of this, we have what is called as multi-tenancy. That is more than one account, more than one user sharing the same underlying resource. And this is what, as I said earlier, helps cloud to scale up, so that you don't dedicate machines to any one person, but you share all the resources that you have. So you pool the resources and share the resources. And depending on the usage, depending on what the user needs, you will, from this pool, dynamically allocate the resources to the user. Whereas in contrast, in the data centers, resources are generally dedicated to a particular group. So you have a development system, you have a system which is dedicated to finance for running their SAP, you have a system dedicated to human resources, and so on. So it could be very different in data centers. Of course, a lot of virtualization happens in data centers as well, but the level of resource pooling that happens in cloud is much higher. The next one which comes up is rapid elasticity. And this is a very, very important value proposition of the cloud. What does rapid elasticity mean? Rapid elasticity means that you can scale out whenever you want, or you can scale in or scale down whenever you want. What does that mean? It means that, let's say I'm running 5 systems and I'm having them as web servers, and suddenly I have a need to expand this. Maybe it's the festival season where I'm getting more people buying from my site and so on. So I want 5 more systems. So all I need to do is to go to the portal, ask for 5 more systems, and the 5 more systems start immediately. And therefore from 5 I've become 10, and after some time when the demand goes down, I can release the other 5 and have the original 5 with me. In this way, I've scaled out, I've scaled in almost instantaneously. This is very important, because if you are not able to do that, then cloud doesn't really have a great value proposition. This value proposition is very important because if you were to take your own data center, if you were to take your own company, if you want 5 more machines, now procuring these machines is not an easy task. So you have to go through levels of approval. You have to get these 5 machines either on rent, or you have to buy these 5 machines. And if you buy, this will be excess capacity for you. You can't release it off, and so on and so on. So there are huge problems when you want to scale up in a data center type of environment. Whereas in a cloud, the whole idea is to allow you to scale whenever you want. So this rapid elasticity allows many companies to experiment. For example, you want to run a marketing campaign and you require 3-4 machines for that. The campaign is going to run for 10 days. So you bring up machines, use it for 10 days, and then give up the machines. So it's cost effective and it's very fast because you get the machines instantly and you use it only for the time that you want, that is for 10 days, and then you release them. So which brings us to the fifth and the final characteristic of the cloud. And this again is an important characteristic which defines cloud. That cloud bills you as per what you use, or what is called as a measured service. So they measure the amount of usage and at the end of a month bill you for the amount that you have used. So what does it mean? So let's take, you're running a server, then they measure for how many hours in a month your server was up and running. Let's say your server is up 12 hours a day and other 12 hours you shut down the server. Then you get billed only for 12 hours per day, not for 24 hours. So the billing becomes an hourly billing. So you get billed for only 12 hours. So they're measuring the resource utilization. Suppose you store a 10 GB of files in a particular storage, which is provided by the cloud, in a cloud storage, then you will be billed for 10 GB of storage. Suppose you store 20 GB, you will be billed for 20 GB. So which is the resource that is being used, and whether they can, measure your usage on the resource. Once that is done, you are being billed on that. It's exactly like how your electricity or how your water is billed when you utilize it on a per month basis. So in the case of data centers, the billing is not at this level of granularity. So when you take all these characteristics together, you find that cloud is more than just virtualization. A cloud is a combination of a data center with a certain cloud attributes. We spoke about the 5 attributes of the cloud, the 5 essential characteristics of the cloud. And here in this diagram, you can see on the left side are the characteristics of what could be an optimized data center. So a data center is generally consolidated, it is managed, it is virtualized. Most of the data centers nowadays are virtualized in the sense that storage is virtualized, you have virtual machines running in your data center, and they try to make the data center as cost efficient as possible. So that's a data center. But to this data center, when you add the additional characteristics, when you provide for self-service, when you provide for rapid elasticity without any intervention. So as I said, you want more machines, just a click of the button, more machines are available for you. There's nobody intervening in between to try and get you the machines. And then you bill based on the usage. And when you add these characteristics to the data center, then you get a cloud. So remember this. So cloud is not just about somebody managing it for you. Cloud is more to do with self-service. It has more to do with how elastic it can be. It has more to do with how you bill. So this is a major difference between a data center and a cloud. So I hope you now have a clear idea of what is a definition of the cloud when it comes to the characteristics. And using these characteristics, you can now be clear on why an entity is called a cloud and why some entities could be called only a data centers or managed data centers. Thank you. In this module, we will talk about the major cloud companies. The cloud has been growing, and according to IDC, this is one of the predictions that they made, that the cloud would go from 47.4 billion in 2013 to all the way to 107.2 billion in 2017. So, I mean, it's from 2013 to 2017. They have seen this sort of growth. So, they have told that this is the type of growth that would happen. And cloud has been seeing a lot of growth. We've seen that Amazon's growing at a good rate. We've seen that Azure is growing at a good rate, and so on. When it comes to the various companies and where they stand, one way of looking at it is to look at what is known as a magic quadrant, which the company called Gartner publishes. And Gartner has published an IAS magic quadrant. Here, they rate companies along two axes. One axis is what's the completeness of vision of the company, and the other axis is what is their ability to execute. So it's not it's not very good if you have only the vision but you cannot execute, or you're good at execution but you don't really have a vision. Even that is not a good place to be in. So here, if you look at this quadrant, the two companies which fall in a quadrant where they have good vision and where they have great ability to execute, these two companies happen to be Amazon AWS and Microsoft Azure. The other companies fall in different quadrants. So this gives you an idea of the various companies that are in the cloud, especially in the IaaS space. So you have IBM, you have CSC, you have CenturyLink, you have Google, you have multiple other ones which you can see here. The companies like HP exist, there's Rackspace, and so on. In a global market share, you will find that Amazon has a fairly high market share of close to 30%. The second market share happens to be with Microsoft. Here the difference is quite large. At the same time, the rate of growth of Microsoft has been quite high. So it will be very interesting to see how things, develop going into the future. But as of now, Amazon is definitely way ahead of its competitors in terms of the size. The market size and the market share that Amazon has is quite high. In the IaaS providers, what we saw in the graph, so we have Amazon AWS, Microsoft Azure, Google Cloud Engine, IBM SoftLayer, and so on. These are the major IaaS providers. So next, let's look at the PaaS providers. Google App Engine is a major PaaS provider. Microsoft Azure by itself provides a lot of platform as a service, as does Amazon Web Services. Red Hat OpenShift is also a major PaaS provider, and the one who has been there for a long time is Salesforce. Salesforce has a well-known platform called Force.com, which is a PaaS platform which can be used. And IBM Bluemix, with its Watson lab capabilities, is also a very important PaaS provider, and Bluemix is being used quite extensively by many people. Then we come to the SaaS providers, which are the software as service. There are many of them. I'm just listing a few of them. One of them is Salesforce.com, which you saw earlier. Salesforce being a pioneer as far as SaaS is concerned. It's been there for quite some time. Oracle also gives you a database as service type of a database as service type of cloud, as well as it provides you other softwares of Oracle Financials, PeopleSoft, etc. as a software as service. We have Microsoft 365. We know that this is something which we use, and this is also a software as a service. You have SAP has also started providing software as a service, and then we have IBM, which has a lot of software as a service with it. So these are some of the companies that we saw. It's not just a representative sample. It's not the exhaustive one, because there are numbers of companies is very huge as far as cloud is concerned, and we just saw some of the top companies here. And there are going to be more companies coming which will offer you PaaS, which will offer you SaaS, which will offer you IaaS, everything. So hope this gives you an overall idea of where things stand from a market perspective and which are the dominant companies as far as cloud is concerned. Thank you. In the earlier module, I had introduced you to cloud and I had spoken about the characteristics of the cloud. Now let's look at what are the cloud deployment models and what are the cloud service models. A cloud can be classified along two axes, if you can call it that. One, it can be classified based on how it is deployed. Second, it can be classified based on what service it provides. So we call this as a deployment model and the service model. So let's have a look at each one of them. First one, let us talk about the deployment of a cloud. The cloud deployment can be of four types. One, it could be a public cloud. Two, it could be a private cloud. Three, it could be a community cloud. And four, it could be a hybrid cloud. The public cloud is what most of us think of when we say cloud. So it's AWS or Azure or IBM Software or Google. These are all public cloud. What does public cloud mean? It means that anyone can use this cloud. You can just sign up with the service provider and start using the cloud. So it is available for everybody. So that's a public cloud. What's a private cloud? Now, the private cloud is available only to a particular entity. That it could be a corporation, could be a government department or whatever it is. This particular cloud is dedicated to that entity. So it could be built in their own premises. It could be outsourced and somebody else outside can build a private cloud for you. But all the resources are dedicated to you. So if you buy a private cloud, all the resources are dedicated to you. They are not shared with anyone. And only your company would have access to this cloud. As I said, it could be managed by your own company internally, or you could lease it out from some other entity who are private cloud providers. Then we come to the hybrid cloud. The case of a hybrid cloud is generally a combination of two clouds. Usually it should be a public and a private type of a combination. Sometimes your data center, if once it's extended into the cloud, also gets called as an hybrid cloud. So hybrid cloud definition not really very well defined, I would say. The definition is not really written down in stone yet. And I've heard people call a data center which is extended into the cloud, and that solution also being called as hybrid cloud. So you have a public cloud, you have a private cloud. Some people define hybrid cloud as a combination of any two clouds. It could be public or public private. They call this as an hybrid cloud. An example of an hybrid cloud or hybrid IT would be that you have your solution in your company where you have 10 machines, and then you extend this to get another 10 machines in the cloud, and all the 20 machines form LAN for you. If such an extension happens, then it becomes an hybrid cloud. Or you can have a solution where the primary data is stored in your data center, but your secondary data is loaded into the cloud automatically. For example, you can be using some storage gateway that AWS provides to make this happen. Then you get a hybrid cloud. So this is a data center plus a cloud or two public clouds and so on. So this is what is called. So this is a hybrid cloud where the definition, as I said, is not yet 100% written down in stone. But I hope you have an idea now of what a hybrid cloud is. Then there's also something called as community cloud. Here, it's a private cloud, but instead of being dedicated to only one company, we are talking about being dedicated to a group of companies. So let's say you have a university which has multiple colleges under it, and there could be a community cloud for the university, and all these colleges could be using this cloud. So this is called as a community cloud. So here we have multiple stakeholders as far as the usage is concerned, but it's not fully public. It's only available to a set of users. Now, when you compare these models, you can see that when it comes to public cloud, you have a shared environment. You have this externally hosted most of the time. I mean, all these public clouds are externally hosted. Then they are managed externally. The service provider manages them, and they are totally designed by the service provider. So everything is external here. So you have external hosting, external management, and external design. When you come to the private cloud, you have two ways of doing it. You can either outsource it completely. So it becomes a dedicated environment for you, but it is externally hosted by someone. It's externally designed or internally designed. It can be either way. You can design the cloud that you want and ask the service provider to host it. And you can manage it yourself, when the resources could be at the service provider end, or you can ask the service provider to manage it. So here you have internal and external management. The hosting is external, and the design could be internal, done by us. The other option of doing a private cloud would be to self-host it, which essentially means that you have a dedicated environment within your own company. You host it in your own company, you manage it, you design it, and you run the whole show. So it's only for your company, but the hosting is inside your company and not external, and you are managing the whole thing. So these are the different ways in which you can do the private cloud. You can either outsource it or you can insource it. So let's now come to the next part, which is to see the service models. Now the cloud has multiple service models. You'll be hearing a lot of service models in many cases. But there are three models which are very popular and are generally accepted as the major service models of a cloud. So these models are infrastructure as a service, platform as a service, and software as a service. So let's look at each one of them. Let's first take infrastructure as a service. Now in this diagram that you're seeing, you see different colors here. The color at the bottom, the gray that you see in the bottom, those parts are the ones which are taken care by the service provider. Here you will see that the servers, the networking, the storage, the virtualization, all are taken care by the service provider. So what you do is, from the operating system onwards, you will need to take care. So from the operating system onwards, the responsibility of keeping the operating system in the right patch level, keeping your middleware in the right patch level, loading the middleware, loading the applications, backing up your data, etc., etc. Everything becomes your responsibility, whereas the underlying part of the servers and storage and networking, all that becomes the responsibility of the service provider. This is infrastructure as a service. So we come to the next part, which is platform as a service. You see the same color coding scheme here. Now, what is a platform as a service? Sometimes I see people get confused between infrastructure and platform. So they say Linux platform or Microsoft platform and all that. Here, when they say platform as a service, most of the time we are saying a deployment platform. What does deployment platform mean here? Let us say you are designing a PHP-based web application. You have JavaScript, PHP, you have a web application developed. And when you want to deploy this application, you require certain underlying software on which this application needs to be deployed. Like if you want to deploy a PHP-based application, you'll require what is called as a LAMP stack, which is Linux, Apache, MySQL, and PHP. So Apache web server has to be loaded on Linux. So first, on a machine, you first need to load Linux. On top of it, you need to load Apache web server software. On top of it, you need to load MySQL database software, and then the PHP interpreter has to be available. So all these are needed before you can deploy and make your application work. So the standard process which we follow in our data centers would be that you take the responsibility of loading Linux, and then on that loading MySQL, loading Apache, and so on. Whereas in a platform as a service, you get a machine with all these loaded. So in other words, you don't need to load any of this software. All you're going to do is take your software and just put it on the stack which is already ready. So the deployment just happens like that. As this diagram shows, from the IaaS point of view, you would have had the service provider handle everything up to virtualization. But from a PaaS provider point of view, you not only do up to virtualization, but above that, the PaaS provider puts the OS, he also loads the middleware, he also loads the runtime, and gives this whole system to you as a platform. And on top of it, you will be responsible for putting your application on top of it and backing up the data that is there and the usage of the data. That is your responsibility. Everything below that is a responsibility of the PaaS provider. The third service that we get in the cloud is known as software as service. This is the most simple one to explain, in the sense that here you have no responsibility except using the software. So let's take the case of, say, Google Docs. When Google Docs is a software as service, you want to use the Excel sheet there, you want to use the Word type of document there. You don't need to do anything. You just go and use it. The whole maintenance of this software is done by Google. So maintaining the hardware, maintaining the required middleware, maintaining the software itself is done by Google. So there are certain software as service which are used, like Google Docs, Gmail, Microsoft 365, and so on. Here, you don't have any responsibility of maintaining the software at all. So this is called as a software as a service. So here is another simple diagram which tells you this. So you can use any cloud client, which could be a web browser, which could be a mobile app, which could be a terminal emulator, and so on. And you get different services here. So the SaaS service like CRM or email, virtual desktop, games, etc., these are all software as service. Or you can get an execution runtime database, a web server, development tools, and all from a PaaS provider. Or from an IaaS, you can get virtual machines, you can get storage, you can get load balancers, you can get networking, and so on. So this gives you an idea of the different service models which are present in the cloud. And to sum all this up, this is how the overall cloud would look at. This is the NIST definition of the cloud. Every cloud has some common characteristics. Basically, the cloud has to be massive in scale. There has to be homogeneous. It should be virtualized. It should be geographically distributed, and so on. On top of it are the essential characteristics we saw in a different video, where we spoke about on-demand, self-service, broad network access, resource pooling, rapid elasticity, and measured service. And on top of this are built different services. You can build an infrastructure as service, you can build platform as service, or you can build software as service. And then you go on to deploy it either as a public cloud or as a private cloud or as a hybrid cloud or community cloud. So thank you. We'll go and see about different cloud companies in a different module.
This module introduces you to Amazon Web Services. we will first have a look at the history of AWS, how it started, how it evolved, and at what state it is in now. In late 2003, Amazon was still an online retailer. Late 2003, Chris Pinkham and Benjamin Black of Amazon presented a paper in which they mentioned the possibility of selling virtual servers as a service. This was to supplement the income of Amazon.com. Nothing happened till November 2004. In November 2004, the first offering of AWS was out. This was the Simple Queue Service, or SQS. SQS is mainly used by developers in order to communicate between two programs running on different machines. Then it took them more than 1 year to launch the next service. The next service was a more generic service. It was not aimed only at developers. The service is now the very famous Simple Storage Service, or S3. This was launched in the spring of 2006. And in summer of 2006, the Elastic Compute Cloud Service, the EC2 service, was launched. With this, we can say that we entered the era of cloud computing. From 2006, Amazon has made rapid strides. Their pace of innovation has been terrific, and the number of features, the number of services that they keep announcing really shakes up the competition. Have a look at this graph. You can see that in the year 2008, Amazon had only around 24 services. By 2016, that we're talking about 8 years time frame, it has already crossed 1,000 services. So this is the sort of pace at which Amazon has been running. Now, what does this mean to Amazon itself when it runs at such a pace? It means that they can be market leaders. And in fact, they are the market leaders in the cloud infrastructure space. This graph, for example, shows you that Amazon has around 31% market share as on the first quarter of 2016. The competition, which comprises of Microsoft, IBM, Google, put together, do not reach the market share of Amazon. Here, if you see, Microsoft, IBM, and Google probably have around 21-22% market share, whereas Amazon AWS is already in the 31% range. This is something which we expect when a company innovates so rapidly. Not only is innovation leading them as market leaders, it also ensures that they are categorized as visionaries as well. Now, Gartner every year comes up with something called as a magic quadrant. In this quadrant, you see two parameters against which Gartner evaluates various companies. On one hand, Gartner tries to see how complete is the vision of the company with respect to the technology, with respect to the services that it offers. On the other hand, Gartner also looks at the ability of the company to execute on this vision and to make the vision a reality. So if you are good in both the cases, you become a leader. So in this quadrant, where it's called as a leader quadrant, you will see on the top Amazon Web Services. In fact, there are only two companies in this quadrant, that is AWS and Microsoft. Here, it means that both these companies have a long-term vision, a complete vision of where they want to go, and they have the necessary ability to execute and make this vision a reality. Others fall in various categories like being visionaries or challengers or niche players, but Amazon here clearly tops even in the Gartner's Magic Quadrant. So this will tell us the strengths of Amazon. AWS strengths include rapid innovation. As we saw, they are just racing ahead of the competition in terms of the services that they are able to give to the public. The pricing has been extremely competitive. And if you look at the history of AWS, you will see that at regular intervals, AWS drops prices. There have been a huge number of price drops over the years, and even last year we saw pricing drop in terms of S3 and other services. AWS has also been adding newer regions. Recently, in India, they added Mumbai, and London is added, Seoul was added. So when the regions come up closer to you, it is better for you in terms of network speed and in terms of compliance requirements and so on. In order for people to test the cloud, in order to test the AWS services, for many services, Amazon offers what is known as a free tier. So you work within a particular range, then you get that service free of cost. So this allows a lot of people to go ahead and experiment with it and be satisfied with what they see before investing full-fledged into the Amazon infrastructure. Finally, and this is very important, they have excellent documentation on every service that they provide. They give you a step-by-step way of how to use the service. There are a lot of examples, and if you follow that, you will be able to clearly understand what the service provides and how it is going to be useful for you. So given all these trends, it's not a surprise that AWS is the leader in this cloud computing field. And this is one reason where many people, or I would say why many people are joining this AWS bandwagon. And welcome to all of you who also want to get on to the AWS train, which is going very fast. I'm sure investing in AWS is a very good investment for your future. With this, we will end this module. I'll catch you guys later in the next module. Thank you. This module, we will be talking about the various services that AWS offers. This is going to be an high-level overview of all these services. This would give you an idea of the width of services offered by AWS. The AWS services can be grouped as follows. It could be the compute service, the storage service, the database service, networking and content delivery, developer tools, management tools, security and identity management. We also have application services, mobile development services, game development services, artificial intelligence, analytics, messaging, and finally, we have services like business productivity, desktop and app streaming, and migration services. We'll look at each of these services in detail. The first service that we would look at is the compute service. Compute service forms the backbone of almost every cloud service provider, and it's no different when it comes to AWS. So what are the various compute services that AWS offers? Let's have a look at that. Important service from a computer service point of view is the Elastic Compute Cloud, or the EC2 service. EC2 is your own virtual server in the cloud. You can say that EC2 is a web service that provides you with resizable compute capacity in the cloud. We will be seeing the EC2 service in a lot of detail in the coming modules, so I'll not expand further on this here because you will hear me talk about this in due course of time. The next service that we would look at would be the EC2 container service, or what is known as ECS. Nowadays, the container service has become very popular and large number of companies are running their application in containers. Docker containers are the most popular containers now. ECS is a service which is a highly scalable, high performance container management service. It supports Docker containers and it allows you to easily run applications on managed cluster of EC2 instances. Basically, you don't need to own any cluster management software. ECS will help you start and stop the Docker application. It will help you in placement of Docker container based on a resource or availability requirement. The other important service and a very interesting service is the service called Lambda. Now, Lambda is an example of what is nowadays known as serverless computing. Basic idea is you don't need to manage or set up any servers. All you do is you do your code and give the code to the Lambda service. The Lambda service will automatically set up and scale the necessary servers for you. So this will ensure that you are hands off as far as server management is concerned, and yet your code runs whenever you want it to run. You can set up the code to automatically trigger from other AWS services, or you can call it directly from web app or from a mobile app. Lambda as a service is important for the developers, and you may not get too many questions from Lambda in a solution architect program. Similarly, you may not get too many questions from ECS in the solution architect program, but Lambda is a very key component if you are going to give your developer certification exam. The next service that we will see is the service called as Elastic Beanstalk. Elastic Beanstalk is a platform as a service offering from AWS. Basically, it is for deploying and scaling your web applications. You may develop your web applications in Java or .NET or PHP or Node.js or Python, Ruby, Go and such languages. And you would have used web servers like Apache or Nginx or Passenger or IIS. Now, when you do this, you give your code to Elastic Beanstalk or you upload your code into Elastic Beanstalk. Now, Elastic Beanstalk, what it does is it will handle the deployment, it will provision the capacity, it will do load balancing, it will set up auto scaling. Everything is done automatically. At the same time, Elastic Beanstalk will also give you complete control over all these resources. So if you want more granular control and you want to take charge of which servers run, which servers should be shut down, you can do that as well. The next service we look at is Lightsail. Lightsail was started very recently by Amazon, and Lightsail is the easiest way to get started with AWS. Basically, for developers who need a very simple private server solution. For example, you want to spend say $5 a month. If you spend $5 a month, you would get a server with 512 MB memory, a single core processor, about 20 GB of SSD, and 1 terabyte of data transfer free along with the system. So it's a pre-configured system available at a cheap rate so that you can buy that and start using it immediately. So these are some of the compute services that we get from AWS. Let's now go to the storage service and have a look at what options we have in storage service. The most important storage service that you would see is the simple storage service, or S3. S3 is used by many people. It's an object store. It has a very simple web interface to store and retrieve data, and it provides a high level of durability so that you don't need to be worried about losing your file that you have stored with S3. S3 is a service that we will look in lot detail in our course. We then have the elastic file system. Now EFS, as this is called, it provides a simple scalable file storage which can be used with Amazon EC2 instances in the cloud. Now if EFS offers a very simple interface that allows you to create and configure file system quickly and very easily. The storage capacity in this case is very elastic. That means it will grow and shrink according to your needs. Whenever you add files, the storage capacity will grow, and whenever you remove files, the capacity will shrink. So you don't need to worry about capacity at all. Your application will have as much storage as it needs and whenever that needs it. Another important storage service is the Glacier service. Now Glacier is for data archiving. So if you want a long-term, low-cost solution for archiving your data, Amazon Glacier is a service to use. Amazon also provides what is called as a storage gateway. This is a hybrid storage between on-premise storage environment and the AWS cloud. It combines a multi-protocol storage appliance with very high efficient network connectivity to the Amazon cloud. So basically, you are going to get local performance with unlimited scale. The next service that we are looking at is the database service. In database service, relational database service is a very important service that is called as RDS. Now the RDS, what it does is it sets up and operates a relational database in the cloud for you. Basically, you are not going to be worried about backing up your database or patching your database and so on. These administrative tasks are taken up by Amazon. Similarly, any scaling that needs, you want to resize your database, you want to resize your instance, all that will be taken up by Amazon, which means that you can focus on your application and business and leave the database administration to the RDS service. The same relational database, Amazon has its own database known as Aurora. Aurora is an MySQL compatible relational database engine. It combines the speed and availability of high-end commercial databases with the simplicity and cost effectiveness of open source databases. Aurora provides up to 5 times better performance than MySQL with security, availability and reliability of a commercial database at almost 1/10 the cost. Another important database service that AWS offers is Amazon DynamoDB. Now DynamoDB is a NoSQL database service. It's fast, it's flexible, and it can be used with all applications that need a consistent single-digit millisecond latency at any scale. Now it's fully managed by AWS and it supports both the document and key value store models. Another important service that AWS provides in terms of databases is the Elastic Cache. Now, we know that caching is a very important part when you work with databases. You don't want to always go to the disk to retrieve your data. Therefore, if you have in-memory caching, that would be very helpful for you. So Elastic Cache does that for you. It's a web service that makes it easy to deploy, operate, and scale an in-memory data store or cache in the cloud. This service improves the performance of web applications. It allows you to retrieve information very fast from in-memory data stores instead of going to the slower disk-based databases. Amazon Elastic Cache supports two open source in-memory engines, which is Redis and Memcached. The other service from Amazon in this database segment is Amazon Redshift. This is a petabyte scale data warehouse that makes it simple and cost effective to analyze all your data using your existing business intelligence tools. From database services, we move on to the network services now. In network services, Amazon offers us a virtual private cloud. Virtual private cloud will let you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network. This virtual network is defined by you. You have complete control over the networking environment, which means that you can select your own IP range, you can create your own subnets, you configure your own routing tables, your own network gateways. You can use either IPv4 or IPv6 in your VPC, and this will provide you for secure as well as easy access to resources and applications. The network service CloudFront, which Amazon gives you, is a content delivery network service. This accelerates the delivery of your websites or APIs, video content, or other web assets. This integrates with other web services of Amazon like S3, and this gives developers and businesses a very easy way to accelerate content to end users with no minimum usage commitment. That is, you don't need to commit for anything beforehand. It is a pay-as-you-go model, as with many of the other services from AWS. One thing which many people are worried about when they use cloud is the data transfer speeds and the security between your enterprise to the cloud. In order to address this, Amazon has Direct Connect. The Direct Connect makes it very easy to establish a very dedicated network connection from your premises to AWS. You can establish a private connectivity between AWS and your office or your data center or your co-location environment. Now, this can, in many cases, reduce the total network cost. Since it's a dedicated connection, it will increase the bandwidth throughput and you get a better network experience. This also allows you to sort of expand your data center into the cloud seamlessly. Another network service which is used by a lot of people is Amazon Route 53. Now, this is an DNS service or domain name system web service. You are going to get an extremely reliable and a cost-effective way to resolve your names to IPs, which is what the DNS system does. Amazon Route 53 is fully compliant with IPv6 as well. It's a very highly available and scalable DNS service. We will now go to have a look at the management tools that Amazon provides. And management tools are important for us because we want to manage all our resources on the cloud. The first management tool that we have is known as CloudWatch. CloudWatch is a management tool for monitoring the AWS cloud resources and the applications that you run on AWS. Using CloudWatch, you can collect metrics, you can track the metrics, you can monitor log files, you can set up alarms, you can react to events. You will see that CloudWatch can be used to monitor resources like EC2 instances or DynamoDB tables or RDS-DB instances. You can also generate your own metrics, or what we call as a custom metrics, and your applications can send a custom metrics to CloudWatch, and CloudWatch will monitor those metrics for you. Similarly, your applications can generate log, and these logs can be sent to CloudWatch, and CloudWatch will log them for you. Another important service which Amazon gives us is known as CloudFormation. This is an important service for developers and system administration. Basically, CloudFormation is like a template. You create a template and then run this template. The template, you can give what resources you want to start, what are the associated dependencies, what sort of runtime parameters that you have to give, and much more. Once you generate the template, you can run this template and resources will be deployed based on what is written in the template. In that way, you can modify and update these templates whenever you want. In other words, this is an example of infrastructure as a code. So CloudFormation can be thought of as infrastructure as a code. The next management tool that you will look at is AWS Config. Now, if you want to take a resource inventory, you are using a lot of resources in AWS, you want to know how many EC2 instances you are running, how much space you're consuming in EBS, or look at S3 and so on. So with this fully managed service, you can take care of resource inventory, your configuration history, what changes you made to your configuration. Then whenever there is a change in configuration, you can enable notification. So all this will help you in both security and governance. Config also gives you config rules. Now these rules enable you to create rules that will automatically check the configuration of an AWS resource, which is recorded by AWS Config. You can discover what are the existing resources, you can discover what resources were deleted, determine whether your overall compliance against rules is fine, and you can dive into configuration details of a resource at any point in time. Basically, these capabilities will enable you to ensure that compliance auditing, security analysis, resource change tracking, troubleshooting, all these happen without a hitch. Another management tool which helps you in these areas is AWS CloudTrail. What CloudTrail does is it records all the AWS API calls for you which have happened from your account, and then it will create a log file of these and deliver it to you. The information that CloudTrail will capture includes who is the API caller, at what time was the API call made, what is the source IP from which the API was called, what was the request parameter, what were the response element, and so on. So this, as the name indicates, keep a trail of all API calls that were made to the web services. The next management tool here is AWS OpsWork. All of you would have heard about the configuration management tool called as Chef. OpsWork is a configuration management service which uses Chef, and this is used to automate the platform, and this treats configuration as a code. Chef is used to automate how your servers are configured, how the servers are deployed, and how the servers are managed across various EC2 instances or even your on-premise compute environments. The final management tool we'll look at is known as Trusted Advisor. As the name indicates, it's an advisor type of a service which looks at your infrastructure and helps you to see how this infrastructure can be optimized so that you can reduce the cost, your performance can increase, and also how you can make your resources highly secure. So this sort of gives you a real-time guidance to help you provision your resources following the AWS best practices. An important aspect for cloud is security. So we'll look at identity and security and find out what AWS offers in this area. The first and the very important part that AWS offers is known as identity and access management. The identity and access management is the one which allows you to create users, which allows you to create groups, which allows you to create roles, and you'll find that we will make use of this service a lot when we are doing various modules. The next one, which is used by AWS, is known as AWS Inspector. This is an automated security assessment service. Basically, this helps you to improve the security and compliance of the application which you have deployed in AWS. The Amazon Inspector automatically assesses application to check for vulnerabilities and to check for deviations from best practices. After performing such an assessment, the inspector will produce a detailed list of security findings prioritized by the level of security. AWS also offers directory services. In this case, it offers a service for Microsoft Active Directory, the Enterprise Edition. The Microsoft AD service is built on the actual Microsoft Active Directory. This means that you don't need to synchronize or replicate data from your existing Active Directory to the cloud. You can use the standard Active Directory tools and take advantage of the built-in Active Directory features such as group policies or trust or single sign-on and all that. So with Microsoft AD, you can easily join your Amazon EC2 or Amazon RDS instances to a domain and can use the enterprise IT applications like Amazon Workspace with Active Directory and so on. From a security perspective, Amazon offers WAF and Shield. Now, WAF is Web Application Firewall. What it does is it helps you protect your web application from very common web exploits. WAF gives you control over which traffic can be allowed to your web applications and which traffic must be blocked. You can define your own customizable web security rules. So you create such common rules and block certain patterns, such as, say, you have SQL injection or cross-site scripting. So you will ensure that these common attacks are blocked by you using WAF. AWS Shield, on the other hand, is to protect you from distributed denial of service, or DDoS. Now, DDoS is something which everybody is keen to avoid, because that's something which will sort of drain out your resources. So Shield is a managed DDoS protection service that will safeguard web applications that are running on AWS. The next group of services that we are going to see are the messaging services. The messaging services, while used basically by the developers, also sometimes appear as questions in the Solution Architect Associate exam. So let's have a quick look at what they are. We will talk about them in detail later. The first messaging service is a simple queue service. This is a very fast, reliable, scalable messaging service which allows two independent programs on different systems to talk to each other using the queue service. So Amazon SQS will help you ensure that you can decouple the components of applications from each other, of any cloud application from each other. The next service, which is messaging service here, is the simple notification service. This is basically a push notification. This allows you to send individual messages, or you can fan out your messages to a large number of recipients. This is a very simple and cost-effective way to push notification to, say, mobile users or email recipients, or even send messages to other services like the SQS service. The third messaging service that we get is a simple email service. As the name indicates, you can send emails through this service. This is a service that is built on the very reliable and scalable infrastructure that Amazon.com developed for its own customer base. So in this case of SES, you can send and receive email. Again, as with many other services of AWS, you have no minimum commitment, you pay as you go, and you will pay only for what you use. Let's look at some developer services and application services as well. One service which developers would use is known as a step function. Now, a step function was introduced very recently. It provides a graphic console so that you can arrange and visualize the components of your application as a series of steps. So if you have a multi-step application, this makes it very easy for you to run such an application so that you can automatically trigger something, you can automatically track each step, and you will know what sort of retries are happening and so on. And the step function will also log in the state of each step, so when things go wrong, you can go and diagnose them easily. Another app service that Amazon offers is known as Amazon SWF. SWF stands for Simple Workflow Service. Basically, this allows you to sort of put up jobs and track them and coordinate these jobs, whether the jobs run in parallel or sequential. a very important service when it comes to the developers is the API gateway service. Now, what is this API gateway service? API act as one sort of what we can call as a front door for application to access either data or business logic or the functionality of your backend services. Now, API gateway that is offered from AWS is a fully managed service, and it makes it very easy for developers to create an API, to maintain or to publish an API at any scale. This is something which all developers use quite often. From a developer point of view, we need a good source control service when you are doing your development. And AWS Code Commit gives you such a service. Now, Code Commit is a source control service which allows you to host secure and highly scalable private Git repositories. So you don't need to operate your own source control system, or you don't need to worry about scaling your source control infrastructure. You can just use Code Commit. In Code Commit, you can securely store anything, the source code, your binaries, etc., etc., and it works seamlessly with your existing Git tools. Other than having a good source control, what a developer needs is also a good deployment system. Code deployments are tricky, they can be time consuming, and they can run into a lot of problems. So AWS Code Deploy is a service which automates this deployment process. And you can deploy the code to either an EC2 instance or an instance which is running on premise. It helps you avoid downtime during the deployment, and it handles all the complexity of application upgradation. So this is a service which many developers may want to use. And finally, as a part of development and deployment, we have something known as AWS Code Pipeline. Nowadays, the important thing that developers do is known as continuous integration and continuous delivery. So Code Pipeline helps in the continuous integration and continuous delivery part, so that the code pipeline will build, test, and deploy your code every time there is a code change. So you can write this pipeline and the process model that you define. Based on that, it will deploy your code, it will test your code, build your code, etc., etc. So what happens is that you can now rapidly and reliably deliver features and updates. So you can build an end-to-end solution by using the plugins that are given by Code Pipeline. The plugins are available for popular third-party service like GitHub integration or Jenkins integrations and so on. Now we come to some specialty services, as I would call. These are very specific services. Let's take up something like analytics, for example. In analytics, Amazon offers something known as EMR or Elastic MapReduce. Basically, this is a managed Hadoop framework which helps you with processing vast amount of data across dynamically scalable EC2 instance. Right? You can run other popular frameworks like Apache Spark or HBase or Presto and so on this. Then we have something called as Kinesis. This is for analyzing streaming data. So this is a very powerful service. So you can load and analyze streaming data using this service. Stored in Amazon started a service known as Athena. Now, Athena is an interactive query service. This is used to analyze data that you have stored in S3. But in this case, you can query the data in S3 using the standard SQL syntax. Amazon also provides you an elastic search service. So this, you can look at log analytics, full text search, application monitoring, and much more. You have very easy to use APIs here. You have the required availability, scalability, and security required for production workloads. And the service also offers built-in integration with Kibana, Logstash, or with AWS services like Kinesis, Firehose, Lambda, or CloudWatch, so that you can go from raw data to actionable insights very quickly. Another service when it comes to analytics is known as data pipeline. Now, this helps you to reliably process and move data between different AWS compute and storage services, or you can also move from on-premise data stores at specified intervals. With the AWS data pipeline, you can regularly access your data where it is stored, transform the data, process it at a scale, and efficiently transfer the results to AWS services such as S3 or RDS or EMR or DynamoDB and so on. There's another service called as QuickSight. Now, this is a cloud-powered business analytics service. It will help you build visualizations. It will help you perform ad hoc analysis, and basically it quickly enable you to get business insights into your data. Okay, you can connect to your data, perform the advanced analysis. You can create really good visualization and rich dashboards which can be accessed from various browsers. So this is a detail of many of these services. There are other services as well, where I just quickly mention the name of the services, but I'm not going to go deeper into them because these are all very specialized services. The services include the Internet of Things based services, services for mobile development, services for developing artificial intelligence, or to migrate your databases, to develop games, etc., or increase your productivity, and so on. So these are the range of services that you get from Amazon. So from an examination point of view, when you are going in for the certification, you must divide this into three parts. The first part is for the SysOps exams or for solution architect exams, the compute part, the storage part, the database part, the monitoring part, and the identity and security part are very important. Of course, in each of them, not everything would be asked in the exam. Like ECS, for example, the Elastic Container Service, I've never seen questions from that coming up. Similarly, for developers, you must look at the messaging services like SQS, SNS. You must look at Lambda. You must look at DynamoDB. These sort of services are very important for the developers, but many of these services, questions from them don't appear in the solution architect or the system administration exams, though I have seen questions coming up with respect to SQS once in a while. We rarely, if ever, get any questions from these specialty services, though I have seen some questions come up from Redshift or Elastic Cache, but I don't think you would need to worry too much about Internet of Things or artificial intelligence and so on. So as we go into each of these modules, I would obviously be telling you which are the areas that you need to concentrate if you're looking at passing your certification exam. So with this, we come to the end of our module, and we will now go on to our next module. Thank you.